image classification is actually the process of taking an input image and categorizing it into one of several classes, such as here you can see that here you can think of these as different images, and this learning is your CNN model when you will pass different images from the CNN model. So the model should be able to classify them into cats and dogs. So it's a very popular application of machine learning and has many real world applications from medical image to self-driving cars. So you can see that here it's a cat which is classified as dog, and here is a dog which is classified as a cat. So of course your model or CNN will not be perfect. It will make some errors. So we will see how we can improve our model performance. So let's talk quickly what are CNNs. So convolutional neural networks, or CNNs, are type of artificial neural networks that actually well suited for image classification. Here you can see is an image of a cat. So a CNN will use a series of convolutional layers to extract features from this image, and then use fully connected layers. A few of them, there can be 1, 2, 3. We will learn as we proceed that how we can define these convolutional layers, these fully connected layers, also called as MLPs. So after extracting the features from the image, these fully connected layers classify the image into one of the several classes. So these classes can be anything. So here it's dog and cat, but you can classify it as, if you have your own data set, you can classify any kind of images, like if it's a cup or a glass, if it's a plate or something like that. Okay, so quickly, what are the steps involved? So first we will import necessary libraries, and then we will load the dataset. Then we will pre-process the dataset very quickly, and then we will build our CNN, and then we compile and train the model, and of course at the end we will see how our model is performing on some images that are unseen for the model. So this is a popular dataset used for image classification tasks. It's a very simple dataset. It's also included in TensorFlow library, so we don't need to download anything and prepare the folders. We will do it in later videos, but for now we will just use TensorFlow and load this dataset. So it has 10 classes. So like aeroplane, automobiles, these are the 10 classes that are included in this dataset, and then there are total 60,000 images per 60,000 images total and 6,000 images per class. And these are very small images, 32 pixels by 32 pixels. And then this dataset is also already split for training and test set. So we will be using 50,000 images for training, and then 10,000 images from this class for testing. This video we will implement the CNN for CIFAR dataset. So just go right away to Colab. Then we can create a new notebook. Okay, let's just rename it as image classification, and then so we will start writing the code for image classification. So first of all, we have to load the necessary libraries. Okay, we have implemented the TensorFlow and Keras from TensorFlow. Now what we will do, we will load the CIFAR data. To load the CIFAR data, we can use the Keras API. So here you can see there are some other datasets also available. The fashion MNIST, CIFAR-100. In CIFAR-100 there are 100 classes, but for now we will just use CIFAR-10. Now we can just load this data. So this CIFAR data set, when we will load it, so it will have two partitions, one for training images and one for test images. And for training images, we need to define two variables, x for the images and y for the labels. So we can say x train, y train, and then similarly for test set, we will say x test and y. Okay, let's rename it to CIFAR-10, so it's downloading the data. Then it will put the data into these variables. Now we will pre-process the data set, which is normalizing it. And then we will divide it by 255. So what it will do, it will just normalize the image pixels between 0 to 1. And we will do the same for our test images. We can just change this to test. And also we need to convert our labels to one hot encoded vectors. For that, we can also use Keras utilities. So we can convert it to categorical, and and our columns will be 10, which is equal to our number of classes. So we will do the same for our test labels. Here it will be test. So now we pre-process the data. So the next step is we will build over CNN. So for that, we can use some convolutional layers and then the max pooling layers. The convolutional layer will extract the features and max pooling layer will downsample it. So if we pass through a max pooling layer with a filter size of 2, so the input of 32 by 32 will change or downsamples to 16 by 16. So let's define our model. We can use this keras.sequential. Sorry, I made a mistake. We need these brackets. Let's remove it. Okay, now we can define the conv2d layers. So what we will do, we will also import the conv2d layers and also max pooling layers. And we need another kind of layers that is called dense layer for the fully connected layers. Now we can just define conv2d. So the first parameter will be how many filters will be there. So let's say 32, and the filter size will be 3 by 3. And then we can use activation is ReLU. We will choose the paddings as same, so our input and output have same values. So it's giving some error. So I was using small d. Now it worked. We can define a convolutional layer, and then so we have loaded this max pooling 2D. We will use it with a filter size 2 by 2, and then we can repeat it one more time. So after passing through it, over 32 by 32 image will go from this, it will reduce to 16 by 16, and when it will be passed through the second max pooling layer, so it will be 8 by 8. We can use one more convolutional layer. In fact, we will see how the performance, and then we can change the CNN accordingly. Now we need another type of layer, so the output will be now 4 by 4. We need to flatten it. So we will use flatten layer. It will just simply flatten the 4 by 4. So it will be 16 pixels, or you can say 16 values. And then we can use dense layer with 64 neurons. Activation will be ReLU. And then another final classification layer with 10 neurons, which will be equal to the number of classes. And the activation will be softmax. Okay, so we have defined our CNN model. Okay, we missed some commas. That's it. Flatten. Okay, we need to run it again. And now we can see it's done. So the next step is to compile and train the model. So we will compile the model. So we need to select optimizer. We will use Adam optimizer with default parameters. And then our loss will be uh, categorical cross entropy, and it will be from logits equal to true. Then of course we have to define our metric. It will be accuracy. Let's see. No attribute categorical cross entropy. Yes, so we are able to compile our model. Now we have to train the model with training dataset. So we will just say model.fit, and we will use xtrain. These are our images, and ytrain. Then we have to define epochs for how many times we need to pass all the data. So it will be 10, and we can say validation split will be 2%. So this data set is really big, so it's taking around 1 minute. So what I will do, I will change runtime here to GPU, and then I will train it and get back to you. Now I have changed the runtime to GPU. Now you can see it's much faster, and also I made a mistake because I'm using softmax layer, so there is no need for this. So now you can see it's taking around 8 seconds to complete one epoch, and then after that we need to evaluate our model. So we will So we will just print the test loss and accuracy. Accuracy will be okay. So this is running. Let's see. It will take some time. Okay, so now you can see our accuracy is around 70%. I will finish this video here, but in the next videos I will tell you how we can improve this performance. I will also plot some different matrices to measure the performance of our model. I will also try to improve this CNN model, and also how we can save the best model for future use. And another thing, I will also show you how you can use your own dataset. Here we use just the CIFAR-10 dataset from the Kira. So but in the next videos I will explain how we can use our own dataset. We will make different folders for each class, and then we will load it and pre-process it. So if you like my content, please subscribe to my YouTube channel, and see you in the next video. Bye bye.